Hello, good morning. Sorry, good afternoon. How are you today? Couldn't be better, right? Okay, right, good. Um, Last week we have a brief introduction about chemical engineering. So I hope you understand the role of the chemical engineers and the basic knowledge of the chemical department of chemical engineering and what you are going to do or what you are going to learn in the department. Right. So today we move to the chapter 2, which is introduction to engineering calculations. And this chapter is very easy, so I will go very fast. So please work with me. We can do this very well. So first of all, let's think of the process. So what is process? As I just talked to you in last week, there are two types of process. One is chemical process. The second one is physical process. And as a chemical engineer, you need to learn both, either chemical process or physical process. So what is process? I hope you still remember this is the mass production of the penicillin. So there are, as you can see, this is a kind of reactor. Although you don't know what is this, okay? You probably understand Chinese, but you don't know how it works. But anyway, this is kind of reactor, which is chemical process, physical process, and there are some physical process. So if you put this process together to become processes, you need to integrate all the processes together. So this become a mass production line. So in this case, you put the raw material into this process, okay? And then you will go through these processes, and eventually the product come out. So you get a product. So this is the mass production of a penicillin, okay? So as an engineer, you need to understand each process, and you need to know how to connect process to process, okay? And make a best production rate or make a very good mass production line. So this is another process called polyethylene production. So as you know, in the previous slide, we talked about penicillin mass production, and now this is polyethylene production. Do you have any idea what is polyethylene? Oh, no. If you don't, this is ethylene, which is in the gas form. So this is a gas. Okay, you put a gas into this physical process, chemical process, physical process, physical process, and then after that you got the products. So this ethylene become polyethylene. What's the polyethylene? Polyethylene, the chemical form is like this. So you have a lot of this, and you make it become this. N is infinite, is very huge. So that's why we call poly. Okay, it's kind of plastic. So in the end, the raw material is in a gas form, and the final product you get is in a solid form. So it's solid. Okay, it can become a pellet. It can become a tube. You can make this material become a rubbish bin, or you can make it become a sheet. So this is made of the polyethylene. So this is the process. Okay? And you might say, wow, Professor, I don't know what is this. Don't worry. You will learn this when you are in second year, and you will learn this in the third year in this college. Okay? So when we talk about this process, penicillin mass production process or polyethylene production process, do you find any similarities? Yes, they are all chemical process or physical process. So for example, you might have a kind of separation process in penicillin production. You might have a separation process in the polyethylene production. So they do have reactor, they do have filtrator, they do have dryers. Okay? So this is kind of chemical reaction process. This is physical process. So for the dryer, You need to know how to separate something in a solid away to the gas. For example, if you want to dry something, you need to vaporize the air, right? Sorry, you need to vaporize the water. So water will come out from the solid, and you got a product which is in the solid form. Okay, so this is the process. Okay, so the process become processes. So we have, as I just mentioned, this is all chemical manufacturing processes. Or you can go through the genetic engineering laboratories. There are many processes. Okay, and also pollution control facilities. So any similarity? Yes, they do. They all run the process. One process, two processes, three processes become a production line, right? Okay, so as a chemical engineer, you need to learn process, and you put the process together. So the definition of the processes is that the system described involve process designed to transform raw material into desired products. Okay, so raw material, in the end, you got the products you want. So raw material go to one process or two processes, three processes, whatever. And in the end, you got desired products. Okay? So what do you, if you have only one single unit of the process, what do you think, how are you going to run this, or how are you going to design this? There are many conditions. For example, in this process, you might need to consider the size. You might need to consider the amount of the raw material you want to fit into this process. You might want to think of how fast the product will come out. So the flow rate in and flow rate out. You might want to think of the composition of the A material, B material, C material, and put it together as a mixture, and then fit to the process. So the composition of A, B, and C raw materials, that's the things you need to concern. Okay, and also you might want to think of the temperature. Yeah? How high is the temperature? 100 Celsius, 1000 Celsius. Okay, or you might think of the pressure. 1 atmosphere, 3 atmosphere. Okay, or 10 atmosphere. So these are the conditions you need to think, and this is the process. When you want to work on the when you want to work with a process production rate or production, you need to think of this some kind of parameters or conditions. Okay. Right. So this is the basic chemical engineering processes. Is that, for example, you need to store the raw material, right? And you need to do the process, pre-treat the raw materials, and you put the raw material to the reaction. This is chemical process, right? And once you get reaction, you might not have 100% conversion rate. So you might have 80% products. You might have 10% byproducts. You might have 10% raw material. So you need to do the separation, right? So this is byproducts. And if you have 10% raw material, you need to recycle and then feed to the pre-treatment, right? And once you got 80% products, you need to feed this to this chemical process or physical process. And in the end, you got products, okay? Pure products. So you don't need to remember this, but because once you're already involved to the some kind of production, you will understand this. So I just give you a brief information to let you understand. So the object of this text, of this lecture, is that we want to let you know the systematic approach to the solution of the problem. So when in the chapter 2, you're ready to do some of basic calculation as a chemical engineer. So we want to show you how to do this systematically. And part 1 is the best techniques. Part 1 involves chapter 2 and chapter 3. Okay? And so the part 1 is the expression the values of the system variables. And then we need to know how to set the volumes. And after that, we're setting up and then solving the equation. We get an answer. So it's all to do with the problem. As an engineer, you need to find the problem. You need to face the problem. And you need to find the problem. You need to face the problem. You need to know how to solve the problem. Okay? So in the part 2, we want to know the laws of the conservation of mass. So this part 2 involves chapter 4 to chapter 6. And this is very important. These 3 chapters are very, very important. And we will focus on these 3 chapters. So once you understand very well in chapter 4, from chapter 4 to chapter 6, I think for the laws of the conservation of energy, there's no problem for you to understand in the part 3. Okay. So what I want to tell you is that we will focus on chapter 4 to chapter 6 in this course. Right. Okay, let's go to the section 2.1, units and the dimensions. Units and dimensions. And in the beginning, let's understand these 2 terms. The first one is called volume. Values. The second term is unit. So what is value and unit? So all the measured or counted quantities has a numerical value and a unit. So once you want to measure something, you want to measure the time, you want to measure the length, you want to measure the weight. Okay, they are all quantity. This quantity has 2 terms, 2 things. One is value, one is unit. I'll give you an example. 2 meters, right? So 2 is value, right? 2 is value. Meter is what? Meter is unit. So you can have different units, right? 2 meters, 2 seconds, right? 2 kilograms. Okay, these are units. So once you have a ruler, this is 1 centimeter, 2 centimeters. So 1 is volume. Centimeter is what? Unit. So you might have 1 inch. This is inch, right? You have 1 inch. 1 inch is what? 1 is value. Inch is what? Unit. But we are talking about all the dimension is called what? Length. Centimeter and inch, they are all related to what? The length. So length is what we know is a dimension. How about 1/3 second? 1/3. 1/3 second is that this is volume, right? This is unit. Easy, right? Piece of cake. Okay, how about dimension? As I just mentioned, inch and centimeter, they all belong to the same dimension, but they are different units. Okay? Inch is one type of unit. Centimeter is one type of unit, but they all belong to the same dimension, which is length. Okay, so the definition is that a dimension is a properties that can be measured or can be calculated by multiplying or dividing other dimensions. This definition looks complicated, but don't worry, I will have a very good example that you know. So dimension is what? Can be measured, right? Or can be calculated. So can be measured is simple, it's easy. Like length is kind of dimension. Time is kind of dimension. Mass is kind of dimension. So as I just told you, length can be what? Centimeter, meter, inch. Okay? These all belong to the dimension of length. Okay? And also the other type is that it can be calculated. So once you have this mass divided by cubic length, so what is this? Mass divided by cubic length, what is this? Density, right? Density. So density is kind of a unit, a dimension. Density is kind of a dimension. How about this? Length divided by time, as the speed. Or you can call it velocity, right? Velocity. Okay, so speed or velocity is type of dimension. Okay? So this is called dimension. So how about second and hour? Are they the same unit or are they the same dimension? Which one? Same unit, right? Different, same dimension, different unit, right? Okay. Right. Okay. So this is the same thing. Easy. So as you know, in dimension you can have very different, many different units. Okay. No problem. And in unit, you can regard unit as a kind of algebraic variables. So what does that mean? So unit can be treated like algebraic variables. What is, for example, 5 centimeter subtract 3 centimeter equal to 2 centimeter. So we regard centimeter as a variables. So 5x minus 3x can minus 3x can be 2x, right? Okay, so you can use centimeter as an x. So once you do the computation, you can define x is centimeter. Okay, so if you regard unit as a parameter or variables, this kind of unit cannot be plus or cannot be subtract. For example, can you do 5 centimeter minus 3 seconds? Can you do that? No, you cannot, right? You cannot. Okay, however, can you do the multiplying or dividing? Yes, you can, right? So 5 centimeter divided by 3 seconds, that will be another dimension, which is the velocity. Okay. So let's summarize section 2.1, units and dimensions. There are 3 key points. The first point is, do you know what's the meaning of the value? Do you know the meaning of the unit? Do you know the definition of the dimension? These are the 3 key words in the section 2.1. Okay? Easy. Okay, let's move to the second section 2.2, conversion of the unit. How are you going to do the conversion of the unit? First of all, we have a term called conversion factor. Conversion factor. So what is conversion factor? Okay, let's make an example. You know that 36 milligram, and I want to make it become gram. Wow, this is easy, right? This is easy. However, another case is 5 nanometer. I want you to make it become how many meters? I'm sure you don't have problem with this since you learned this in primary school or junior high school. But I want you to do it in scientific way, or I want you to do it in the way of a chemical engineer does. Okay? So this is what we call conversion factor. Conversion factor. Let's make an example for you. In the previous slide, we know that 36 milligrams, we understand that will become 0.036 grams. Right? You know that because this mini means what? 10 to minus 3. 10 to minus 3. So that will be easy for you to do it. However, what I want to tell you is that let's do it in this way. I don't know if you learned this in your junior high school or not. So if you 36 milligram times what? 1 gram divided by 1,000 milligrams. As you know, 1 gram equal to what? 1,000 milligrams. Because you know 1 milligram is milligram. A mini is a prefixed. Mini is a prefixed. Mini equal to 10 to minus 3, right? So you understand 1 gram is equal to 1,000 milligrams, and this one become 1. Okay, so you know that this is the unit, and you remove this unit, right? In the end, you will get only this unit left, and you have numbers, values. So 36 divided by 1,000, that means 0.036. So you put the volume together, you put the unit together, and eventually, in the end, you will get this number, right? So this is called conversion factor. This is called conversion factor. Or if you're not happy with this, you say, wow, I don't like 1 gram equal to 1,000 milligrams. You can say 1 gram equal to 0.001 grams. That will be fine. Again, you remove this milligram away from this equation, and then you have a gram left, which is the unit. And you put the number together, you get 0.036. No problem, right? No problem. Okay, this also is called conversion factor. So what is conversion factor? Let's make another example. 5 nanometer equal to 5 times 10 to minus 9 meter. Everybody knows this. Okay? So, and we also know that 1 nanometer equal to 10 to minus 9 meter. So as a result, we know this number and this unit. Okay. However, and of course, you know this is 5 nanometer equal to 50 angstroms. Right. Next thing we want to know is this is called conversion factor. And we want to do it more scientific way, and we want to make it better as a chemical engineer. Okay, and I want to show you another term called dimensional equation. What is dimensional equation? We remove this. I will remove a bar. We put a bar here. And this is called dimensional equation. This make it easier. So 36 milligram, and this is 1 gram, and this is 1,000 milligram, and this becomes 0.036. So in your midterm exam, if I ask you, please, using dimensional equation and conversion factor to express this kind of calculation, please do it in this way. Not this way. This way is not dimensional equation. That means you are not a chemical engineers. Okay? Let's do it in this way. Okay? So, the use of a vertical line, instead of the multiplication symbols. Okay? Right, this is conversion factor, and this is dimensional equation. Okay, easy. Right, so let's do it step by step. Dimensional equation, step 1, write the given quantities and its unit on the left. From the left to the right, okay? And second step, write the units of the conversion factors that cancel the old units and replace them with the desired ones. Step 2. Step 3, fill in the values of the conversion factors. Step 3. Step 4, carry out the indicated arithmetic to find the desired values. Step 4. Well, you might say, well, Professor, please give me an example. so that it will be easier. It will be easier for me to understand. Don't worry, we are going to make an example for you very soon. So this is first example. 1 second, 1 centimeter divided by second power 2. Okay, so equal to how many kilograms, kilometer per year, power 2. So can you do that for me? Can you do this for me? Easy, right? So let's do it in a scientific way using conversion factor and the dimensional equation. Okay, so the first one, we put 1 centimeter in the top, in the top, and second in the bottom. So 1 centimeter, and you want to make 1 centimeter become kilometer, right? So you have, this is second power 2. So let's do it first. This is called numerator, okay, denominator, okay. Nominator is in the bottom, and the numerator is on the top. So if you have centimeter here, so in the denominator here you have centimeter, and you know the centimeter will have a conversion factor with the meter. So as you know, 1 meter equal to what? 100 centimeter. So this is equal. So in this case, you can remove centimeter away and you left meter. But this is not enough because you want to know how many meters become kilometer, right? So here, again, you write down meter and kilometer. So in the numerator here, you know that 1 kilometer is equal to what? 1,000 meter, right? So as a result, you remove the meter here and you left kilometer. Okay? So it's done in the part of the numerator. Okay? So for the denominators here, you start to do the second power 2, and here is, you know, the second power 2, and you change to meter power 2. So you know 1 minute equal to what? 60 seconds. And then from second, you remove the second, right? You remove the minutes here. Okay, you start to remove second first, remove the meter here, minutes. So 1 hour equal to 60 minutes. And next, you remove hours. 1 hour, 1 day equal to 24 hours. Right? You remove hours. Okay, and now you remove the days. 365 days equal to 1 year. So as a result, you year left as a unit here, and kilometer left as a unit here. So once you do very easy calculation, you know that this is the n, and you just 1 times 1 times 1 times 60 power 2, 60 power 2, 24 power 2, and 365 power 2 here. And for the denominator, you have 100 times 1,000. And you do a simple calculation, you will know what is the volume here. Okay? Easy, but takes time. Okay, the important thing is you need to know conversion factor and the dimensional equation. Okay? So let's summarize the section 2.2, conversion factor or conversion of units. So important things, conversion factor, you need to know. Second, dimensional equation. Okay? Next, section 2.3, system of the units. Let me see. Okay, system of units. So let's think of the components. What's the components of a system of the units? So there are three components. The first one is called base units. Base units. Second one is multiple units. Like second become hours. Hour is multiple units, right? Okay. And third one is derived units. Derived units. The speed is derived units, right? So, but basically you need to know what's the base units first. So what is the base unit? There are only 7 base units. First, mass, length, time, electrical current, temperature, luminous intensity, amount of the substance. There are only 7 base units. Okay? There's no number 8. No, there's no number 8. If you find out there's number 8, please tell me. Okay? We get Nobel Prize together. Okay? So there's only 7 base units. Everything include all the units. You can make it become these 7 units. Okay? So this is base units. So how about multiple units? The multiple units is second become time, hour, year. That's multiple units. Easy, right? How about the okay? The third one is derived units. Derived units. Derived units is that a kind of we call derived units as a compound unit. It's a kind of mixed. For example, as I told you, the speed, right? The length divided by time, that's the speed. Speed is derived unit. And how about this kilogram times meter divided by square, second square? What's this? What's this? Energy, right? Energy. Sorry, Newton, right? Force. Sorry, I'm sorry. Force. Right, so, however, you can use these units, but you can also use this unit as a name. This is called Newton. Because we know force is equal to the mass times acceleration. Right? This is mass times acceleration. So we call it mass, a Newton. Okay? Right. So next is the system of units. What's the system of units? There are 3 systems. First one, SI system. Second one, CGS system. Third one, American Engineering System. So in the old time, probably 2 centuries ago, there are many, many systems. And it's too complicated. All the country has their own systems. It make the world a mess, right? We need to have a common language. For example, English is the common language in this planet. So if you want to talk to somebody from Japan, you want to talk to somebody from Africa, you need to use English. English is the common language, right? People use. Okay, you cannot talk Chinese to the Japanese. They don't understand anyway. So this is the system. We use this as a kind of standard. We want to talk in this system. So the base units, I hope you still remember, the base units, there are 7, right? Mass, length, time, electrical current, temperature, luminous intensity, and also amount of substrate. So for the SI base system, what are they? Mass is what? I'm sure you know this. You got it. You learned this in your high school, right? Mass is kilogram, right? Do you learn this? I don't know. Our gap is too far. When I learn, pi, I need to remember 3.14169 something. But, you know, when you learn pi, it might be 3.14 only. But when I was a student, I need to remember pi is 3.1416, blah, blah, blah. Okay. And when I was in England, they just need to know pi is equal to 3.1 or something. Okay. Anyway, so this is mass is kilogram. How about length? Anybody want to tell me? Meter, right? Meter. How about time? Second. Electrical current. What is this? Amp. Ampere. You can call it amp. Okay, temperature. What is this? Kelvin. Luminous intensity. CD. Candela. How about amount of the substance? Mole. Okay, so there are 7 base units, and this is the SI base units. I hope you remember this. I hope you remember this well. Okay, and I'm sure you know this well too. Okay. So in the Kahoot next week, or in the midterm exam, if I ask you to write down voltage, so if I give a question, express the voltage using the 7 SI base units, I want you to use this 7 to express voltage. Can you do that for me? Can you? Okay, you might say, well, Professor, what I learned when I was in high school, voltage equal to current times resistance. That means A times what? Ohm. This is the unit of the resistance, right? This is the A, current is the ampere. So A times ohm. Can you write down this for me? No, I want you to write this as the 7 SI base units. So ohm is not belong to this 7. So what can you do? Okay, you have to go back to the definition of the voltage. The definition of the voltage is 1 volt is defined as the differences in electrical potential between 2 points. 2 points of a conducting wire when an electrical current of 1 ampere dispenses 1 watt. This is the power. This is the power. Okay, of the power between those points. These 2 points. So you cannot express voltage as a unit like this to me, because this is wrong, of course. You want to use this 7 base unit. So the SI base unit is like this. The voltage is potential energy divided by charge. So this is the definition of the voltage. So you know the energy is force times what? Length, right? Force times length. So Newton times length, because this SI, so we use meter, divided by what? Charge. What is charge? Electrical charge. So electrical charge, we use Coulomb to represent electrical charge. Of course, you understand Coulomb is not in these 7 base units. So the definition of Coulomb is what? Is amp times second. Amp times second. So you put this together, this kilogram, meter, second power 2 amp second. So as a result, the voltage of to express the voltage using 7 SI base unit is this. And this is the answer you need to give me. Okay? Right. Okay, so we understand SI base unit. How about CGS base units? There are only 2 unit differences, length and mass. I think you understand. For SI, it's meter. For CGS, it's centimeter. Right? For SI, is in terms of mass, for the SI is kilogram. For the CGS, is gram. Others are the same. Okay, so this is not difficult at all. I hope you get the point very easy. Right, so before we move to the next section, it's important to know a kind of prefix. I hope you understand the kilogram. We call kilo, right? We use K to instead of kilo to represent kilo. Kilo is 10 power 3. Mega is 10 power 6. Giga is 10 power 9. I'm sure you know this when you have your memory disk, right? Flash, or we call memory disk. And we use, a giga, 5G or 128G, And now you go to tera, right? Tera, 1 TB, which means that this memory stick has 1 terabyte memory, right? Terabyte. Terabyte is what? 10 to 12. I don't know when you will go to penta, 10 to 15th. That will be huge. As if we talk about memory, right? So it can go up and go up a lot. How about a prefix to represent something which is very small? We know the centimeter, right? Centimeter, millimeter, micrometer, nanometer, picometer. And this is what? Femtometer or femtosecond. It can be femtosecond, right? Right, so this centi is minus 12. And minus 3, micro is minus 6. Nano is minus 9. Pico is minus 12. Femto is minus 15. So if we talk about femtosecond laser, laser can have a pulse which is in the time of 10 to minus 15 second. That's what we call femtosecond. Okay? A nanometer, you understand, right? Nanometer. Right, okay. So for some derived units, here is for you to understand area, value, they are all derived units, okay? Value, density, force, pressure, energy, power, frequency, electrical charge. You remember that? Electrical charge. Q is A times second. Ampere times second. We call it Coulomb. Okay? Electrical potential difference, voltage, V, right? You remember this unit? Okay? Electrical resistance, ohm. So if I ask you, can you represent ohm using 7 base unit for me in a Kahoot next week? Can you do that for me? Yes, you can, right? Open book, so you can do a calculation with your lecture note. Right, okay, so the system of the units is that American engineering system. As I just told you, SI system, CGS system, and here is the American engineering system. Americans still control the world. What they say, they are the big boss in this world. So they have their systems. Of course, the systems are originally from United Kingdom. But anyway, length, we know that is what? Length is feet. Mass is pound. Right? Time is what? Time is second. So American engineering system, we call AES system. Length is feet. Mass is pound. Time is second. The same as SI system and CGS system. So now you need to know the conversion from the feet, because this is all related to the length, right? So you need to convert the feet to what? To meter or kilometer, right? You need to convert pound to what? To kilometer, a kilogram or gram, whatever. So this is what we call conversion factor. So how we convert units? For example, in United States, if you play NBA, they will tell you this guy, how tall he is, what's the weight he is, right? He will use how many feet, how many pounds he is. And the temperature, the definition of temperature, the unit of the temperature is different. So how to convert the units? Very easy. Now you Google it, right? You Google and you know that. But when I was young, we need to remember. But anyway, here you don't need to remember. There are only 3 things I want you to remember here. Okay? 3 things. Please remember this. Length, this is called conversion. So the first one is that 1 inch equal to how many centimeter? Or how to convert American engineering system to SI system. So in Chinese, 1尺等于12寸 right? 1寸等于多少公分 2.54 公分 right? So, but if you don't want to remember 2.54, you can remember 25.4 millimeter. It's all up to you. But what I want you to remember is you want to simply quick calculation how many 1 inch equal to how many centimeter or how many millimeter. In your midterm exam, I won't give you this number. So you need to remember. Okay? Others, only 3 things I want you to remember. Others, I will give you. Okay? How about pounds? 1 kilogram equal to 2.2 pounds. I want you to remember this. Just in case if you go to the United States, they ask you what's your weight? Or how many kilograms? They don't understand. They don't have any idea about kilogram. They just know how many pounds you have. So 1 kilogram equal to 2.2 pounds. And 1 pound equal to what? 0.43 kilogram. 45 kilogram. I always remember 0.454. Anyway. So this is the second one I want you to remember. 1 is length. 1 is weight. 1 is what? 1 is temperature. Okay, I want you to remember these 3. How do you convert Fahrenheit? Celsius to the Fahrenheit. United States, they use Fahrenheit, right? And then in Taiwan, we use Celsius. So I want you to remember these 3 conversion factors, and I will give you the rest of the numbers. For example, how many bars equal to 1 bar equal to how many psi? This is pressure, and the flow rate, and the energy or the power. Don't worry about this when you do the calculation. Again, please remember these 3 conversion factors. Right, so here is the example. 23 pound mass times feet divided by square minutes to equal to its equivalent in kilograms times centimeter divided by second square. So can you do that for me? Can you do this for me? Using conversion factor and dimensional equation. Okay, so first of all, you write down the dimensional equation first, and you put the conversion factor in the dimensional equation. Okay, and then you put the unit first, and then you put the number. Right, unit first, and you put a volume or number in. Okay. So let's do it first. 23 pound mass. This is pound, right? Represent mass. Later on, we'll introduce one is called pound force. It's different from the pound mass. Pound sub M, M stands for mass. If I write down pound F sub S sub F, F stands for force. So you'll notice very soon, okay? Pound mass times feet, and then you have minutes, power 2. And you want to change to pound mass to become kilograms. So you have conversion factor, pound mass, 1 pound mass equal to how many kilograms? And we just know this, 1 pound mass equal to 0.454 kilogram. Okay, so you got the unit of the kilogram here now. You remove the pound mass. And now you want to have length. So you have 1 feet. and equal to how many centimeter? 2.5, 2.54, right? 2.54. 1 feet equal to, oh, sorry, it's inch. Okay, and now you want to go to feet, right? So you need to 2.54 times 12, right? So that will be 30.48. And now you remove the feet here, you have centimeter. Again, you want to have minutes power 2 and minute power 2, you have second power 2. So you remove the minutes and you let the second left here. So in the end, you got this unit. And now it's the time, now you know that you have to do the simple calculation with this 32, 0.45, 0.454, 30.48, and times 1. Divided by what? Times 1 times 1 times 60 square. So this is the answer you will get. Okay, I don't want to waste your time. This is the answer, and very easy. Okay, so you might ask, Professor, why this is so important? Why we need to learn this? Why we need to learn pound change to kilograms? Why can we unify in one unit only in the world and everybody use this? Everybody is happy. Well, this might be a good idea, but on the other hand, this makes the world interesting, right? Interesting. So I want to tell you one of the stories that don't confuse the numbers. You need to learn this very well. In 1999, there's this orbiters lose because there's one team engineering, they use metric units, and one team use English unit. So they don't mix each other. So in the end, this orbit lose, right? They are about to do the celebration because this orbital will be in the Mars and to do its job. But in the end, it crashed, lose a lot of money. Engineers lose their jobs because of this. You don't want to let this happen to you, right? Okay, so I told you this, and you need to learn this. And you need to learn this well so you don't lose your job. Right, so section 2.3 conclusion is system of unit. You need to know, and there's 3, right? And the conversion between the system of the units. So now let's move to the section 2.4, force and weight. So we understand force is kind of, the definition of force is the mass times acceleration. That's the Newton's second law of the motion. Everybody knows this when you are in junior high school. So this is the mass times acceleration. So for the SI system, we understand if we put SI system, mass will be kilogram, and the acceleration will be meter divided by second square. So as a result, this is combined of the base unit. But of course, we can use derived unit. We call this Newton, right? Newton. How about CGS? CGS is 1 gram times centimeter divided by second power 2. And that's what we call dyne. How about American Engineering System? So the mass, because for the mass is pound, right? Pound. And for the length is what is 30 is feet, 32.1 is feet. So we use this pound force as a kind of derived unit. And the mass is pound mass, right? So it's pound mass and times feet. So as a result, this is the called pound force. So what we know is that if you want to use dyne and you use use 7 basic units here, that will be 32.174 pound mass. Okay, so ladies and gentlemen, I want you to remember this is a little bit, you need to be careful with this. One pound force equal to 32.174 pound mass times feet divided by second square. Okay, here is simple, right? Here is simple, because the definition, Newton is different from this, right? But this is the pound force and pound mass. Okay, but anyway, it's easy for you to use acceleration because we use weight. Weight is a gravitational acceleration. So if you think of the gravity, and this is the gravitational acceleration G, is 9.8 meter per second square. So that's why 1 pound force is equal to 32.174 pound mass. Okay? Yeah. I'm sure you understand this. So let's do a very simple exercise. So for the SI system, weight and the mass. So if you have a 4 kilogram mass and then acceleration is 9 meter per second square, that will be, if we want to know the force, that will be easy calculation, will be like this, right? So it's 36. So we already put this acceleration here. And how about American engineering system? 4 pound mass and 9 feet per second square. How many pound force? We should write. So the force equal to mass times acceleration. Again, you have 1 pound. You have 4 pound mass, right? And you have feet square. This one, right? 9 feet per square second square. And because of this, you want to make it become pound force. So you need to have what? Conversion factor. So this one equal to 32.174. This unit become 1 pound force. So as you know, you remove this, and you do a simple calculation, will be 1.12 pound force. I don't want to give you trouble. I just want you to remember this. It won't be Kahoot, or it won't be in your midterm exam. But please remember this: pound force and pound mass. There's a conversion factor which is 32.17. Okay. Right. So the definition of gravity is 9.8. You know that 980 and 32.17. So this is easy calculation. Conclusion. You know the definition of force and weight, and you know the definition of gravitational acceleration, G, because you consider why we have this kind of systems. As I just told you, 2 centuries ago, there are many different type of units. Even you have many different type of languages, right? And accents. In Taiwan, we have more than 4 type of accents. Okay, and you have different languages in all over the world. So for the basic units, we all want to have kind of things to define the meters or the seconds or right. So this is summary from the. So first of all, we need to know the process, right? And base, multiple base unit, multiple unit, and derived units. And this is important. You know what I mean, right? 7 base units. Okay, and then conversion between units, you need to have a conversion factor dimensional equation. And then for the force and weight, you need to be aware of the pound force and the conversion factor between pound force and pound mass.